So in our last video we talked a bit about sample proportions. In this video we're going to talk about sample means. And you do need to be aware of when you're dealing with a sample proportion versus when you're looking for a sample mean. An easy way to figure that out, I think I mentioned this earlier, is that if you're looking at values between 0 and 1, you're dealing with proportions. If you're looking at a bunch of values that are greater than 1, then you're dealing with sample means. So the first thing we need to do is review notation. When we use the symbol mu, that refers to our population mean. And when we use the symbol x bar, that refers to our sample mean. So you do need to be careful to keep those two straight. Now, in our last video, we found how to calculate the mean of our population, or excuse me, our sample proportion, p hat, and we also found a formula for our standard deviation of p hat. And similarly, in this video, we're going to talk about how you find the mean of x bar and the standard deviation of x bar. Last video, we saw that p hat was equal to p. So our population proportion, the mean of our population proportions is equal to, excuse me, I keep saying that, the mean of our sample proportions is equal to our population proportion. So it probably won't come as a big surprise that the mean of our sample proportions should just equal mu, which is our population proportion. No big surprise there. Again, I'm not going to bore you with the derivation for the standard deviation formula, but if you're interested in seeing it, you can come talk to me and we can work through it together. But the formula that you need to be familiar with is that the standard deviation of x bar, so the standard deviation of your sample mean, is the standard deviation of your population, so sigma, divided by the square root of n, where n, again, is your sample size. You might be wondering where that square root is coming from in the denominator of that fraction. Just keep in mind that, and this is something we've talked about previously, any standard deviation is the square root of your variance, which is sigma squared. So that might sort of clue you in to where that square root of n is coming from, if you think about it a little bit. So you do need to keep some things in mind here. What we're doing is we're saying we're creating some sampling distribution where we're taking a bunch of samples and we're seeing what value we get overall, and we're taking the mean of those values. And that mean x bar is our estimate for our population mean mu. So as the number of samples gets bigger and bigger, we expect the value of x bar to get closer and closer to mu. So there are a few conclusions that we can make from this. First of all, the sample mean x bar, that's going to be an unbiased estimator of the population mean mu. And remember what unbiased means from a couple videos ago. The larger our samples get, the more samples that we take, the less spread out our values for x bar should be. So our variance should be decreasing. And also, these last two formulas that I showed you, just like we talked about in the last video, you should only use these when your population is at least 10 times as large as your sample. Remember, that was the same rule we had when we were talking about sample proportions. One last thing that you need to be familiar with is that just like with our sample proportions, there will be times when we can use a normal distribution to be an estimate for our sample distribution. When we're talking about sample means, we're going to be able to use the normal distribution as an approximation when our sampling distribution is coming from data that is also normally distributed. When that happens, then our sample mean for x bar is it's going to be, sorry, I keep saying this wrong. Our sample mean x bar will have the normal distribution of our underlying data. So that means it's going to be normally distributed with mean mu whatever that normal distribution from our data is, and the standard deviation will be sigma over the square root of n, which is very much related to what we just talked about. So this is the sampling distribution of x bar will have this normal distribution that can be approximated from it.